Good morning, friends. In the last class, we discussed on underfitting and overfitting. It's important interview question. And after that, we started our discussion with regard to the bias in the model. We looked at the definition of the bias, and then we also looked at, the main idea behind model building. Do we need a model which is complex, or do we need a model which is simple, or what kind of a model we need to develop right now to address the problems. And we also looked into a very basic information pertaining to the actual value and the predicted value. Okay, now let's further discuss in terms of concepts, so that you will be able to give more information and more clarity when questions are asked with regard to the bias. Okay, let's say that like you are trying to hire a candidate, okay, and you're trying to hire a candidate to do some work, and you are biased, and you hire a particular person for the work. So what will happen after you hire? The performance of the candidate will not be up to the mark, because you skipped a lot of process which is needed to check if the candidate is really capable of doing the work or not. And you will have more error in the work which has been done by the particular candidate. Correct. The same thing happens in terms of a model. Sorry, in terms of you having a data which is having bias. Let's say that you have a data, and the data, let's say that it has got bias. So what will happen is, due to the bias, the will be performance of the model would be very poor. Okay, and if you look at the data accuracy, the model accuracy will also be very low. Okay, so this is a parallel which I have shown you, explaining using intuition and a practical example. Okay, so it is not advisable to have bias in the data. Okay, what will happen is, when you have bias in the data, the model performance will be very low, or it will be very poor, and the accuracy will also be affected. Okay, so please do bear that in mind when you are trying to develop the model. And next is that, there are different things which would happen when you're trying to develop a model, right? The bias that we talked about, it could be either low or it could be either high. Okay, when the bias is very high, what will happen? Bias is basically the error, correct? It implies that the error is very high. Okay, and the error that exists between your actual and your predicted. Okay, the error that exists between your actual and the predicted will be very high. Okay, so this will happen when you talk about a model which is having very high bias. Okay, when the bias is very high, remember that the error is going to be very high, and the error is nothing but the difference that you see between your actual and your predicted, or the distance that you see between your actual and the predicted, and that is going to be very high. Okay, this is for the first scenario when the bias is very high. Okay, now let's consider the second example, or the second line, wherein I'm talking about the low bias. So this is again going to be the total opposite of the first line. Okay, when the bias is low, it means that the distance is very low. Okay, the distance that exists between your predicted and the actual is going to be low, or the error is going to be low. Okay, so this is self-explanatory, because there is no much complicated stuff to understand over here. Okay, but please do bear that in mind, what will happen when you have high bias and low bias. And let's also look at this particular information. Okay, this is also again very important. Okay, a lot of questions will be asked in terms of relationship that exists between bias and underfitting. Okay, so when the bias is very high, what will happen is, the model is not able to understand the relationship between your actual and your predicted. Okay, so what will happen is, the model is not able to truly get the essence of the data, right? So what will happen is, it will lead to very high error. Okay, and the error is going to be there both on your training and also in your test data set. Okay, so when the bias is very high, it will lead to underfitting. Okay, so basically what you have to remember is, when the bias is very high, okay, it is not able to understand the relationship, okay, between your test and your train. Okay, this happens both for your test and the train. Okay, the relationship that exists between the variables, even for the test data and also for the trained data gets affected. Okay, like it is not able to truly get the essence of the data. Okay, so what will happen is the performance is going to be very low and results in underfitting. Okay, it is very simple as that. Okay, now over here what I have given you is, here is, okay, this is the graph that clearly explains what is happening in terms of underfitting. I think that we saw it in the last class. So all the pink dots we have here, all the pink dots are your actuals. Okay, and the blue line is your target, or what is being predicted by your model. And there is a red box, okay, which will be your test data. Okay, now if you see carefully, there is a gap that exists between your target and that of your actual. So this is basically an error, right? Likewise, if you look here, this is your box, the red box, and this is your value which is being predicted by the model, right? Over there also you find error. So it is performing very bad both in your test and also in your training test set. Okay, which means that the model performance is not up to the expectation. Okay, so the pink dot are the actuals, which means that I'm talking about your training data set. Okay, the pink dot is the actual. Okay, and this belongs to the training data set, and the square is nothing but your target, right? Sorry, it is a part of, it is also an actual. Okay, it is a part of your test data set. Okay, that's what I'm talking about over here. Okay, so over here what I'm seeing is there is an error that I see happening both on your training and also the test data set. Okay, and because of that, what it is going to do is it is going to have underfitting. Okay, so this is that. Now let's look at a few more concepts with regard to the relation that exists between algorithms with bias. Okay, now if you look at models like linear regression, linear discriminant analysis, and logistic regression, okay, you will have high bias. Okay, on the other hand, if you look at algorithms like decision tree or k nearest neighbors or support vector machines, you will find low bias. Okay, this is something that you have to keep in mind. Okay, like we will look into these things very detailed when we cover when we cover the linear regression and the other models. Okay, as we go by, right? For the time being, remember that there is a relationship, right, that exists between your algorithms and the bias. Okay, there are a few algorithms which will definitely have high bias. That is going to be your linear regression, logistic regression, and then linear discriminant analysis. And your decision tree, support vector machine, and your k nearest neighbors are all the models which is going to have low bias. Okay, so now let's go to the next header, right? Wherein we are talking about the ways or methods by which you can reduce the bias. Okay, the first thing is that, like when you understand there is no linear relationship that exists between your actual and that of your target, then don't use linear model. Okay, so this is your first method by which you can reduce your bias. Okay, the next method is that the next thing that you have to check is that the data has to be representative. It should not have any kind of bias. And the third one is that the data should not have outliers. Okay, and then we need to have sufficient data points in the in the analysis. Okay, like let's say that, like you have very less data, then what will happen is that you are bound to have bias. When you have sufficient amount of data, then the bias gets rolled out. And outliers, okay, outliers, when you have outliers and if they are not treated, then you will definitely have bias when the model tries to understand the relationship that exists between your actual with that of the target. Okay, now this, the last 2 points, right, these are the most important, okay, which anyone would expect when you're asked this question, which means that you have to increase the complexity of the model. Don't make the model to be simple. Okay, like you can go for second degree or third degree polynomial equations. Okay, so that will definitely help in addressing bias related issues. And then the next thing is that try different models. Okay, like you can try random forest or knn, or you can try support vector machines, right? So when you try these things, then your bias would definitely get addressed. Okay. So this is these whatever that I have mentioned over here, or the content that is related to the bias, and you can expect questions being asked on these topics. Okay, so I would suggest that you can go through it again. Okay, like please post if you have any doubts or questions with regard to the bias. I will be able to help you out on that. Let's meet again in the next class. We will discuss on variance and on other topics. Thank you guys. Have a great day.